Hello, my dear students. Welcome to the session on quantitative aptitude. In this video module, we are going to discuss 10 unique questions from the topic time and distance. So without any further delay, let us get into the questions. You may pause the video whenever you feel it is required. Take your time to read and understand the question, attempt the question, and then be ready with your answer before you are watching my explanations. Please attempt the first question now. All right, dear students, I assume that you are ready with the answer for this question. The correct answer for this question, the average speed for this journey, the answer, it is 50 kilometers per hour. Now, let me share with you the explanation for this question. In this given, it is given, in the question, it is given that Girish, he traveled the first half of his journey time at an average speed of 40 kilometers per hour, and the remaining half at an average speed of 60 kilometers per hour. So, dear students, please tell me what is remaining the same in this particular question. The first half of the journey time, it is covered at an average speed of 40 kilometers per hour. So, when we are considering this question here, if you assume that the total time, okay, consider the total time that is equal to 2t hours, okay, then you can see that the first t hours, it is covered at an average speed of 40 kilometers per hour, and the remaining half, that is the next t hours, it is covered at the rate of 60 kilometers per hour. Okay, you know that distance, it is equal to speed into time. So the first half of the journey time, if you consider the distance covered, it is equal to 40 into t, that much kilometers. The other half of the time, when you consider the total distance covered, it is speed into time, that is 60 into t, that much kilometers. So the total distance covered in this case, it is 40t plus 60t, that is equal to 100t, that much kilometers. That is the total distance covered. Total time taken, you know that it is 2t hours. So the average speed for this journey, that is total distance by total time. So we can consider that the average speed, it is equal to 100t, the total distance, divided by total time, that is 2t, and that gets you the answer here as 50 kilometers per hour. Okay, so this is the methodical way of solving the question. By observation and through practice, you can even see that if the time remains the same, then the average speed of this entire journey, that will be nothing but the arithmetic mean of the individual speeds involved. Here the arithmetic mean of 60 and 40, if you consider it is 60 plus 40 by 2, and that is equal to 100 by 2, and that you can straight away write it as 50 kilometers per hour. But you can take the arithmetic mean when you have the time factor, it remains the same for the first half and also for the second half as indicated in the question. Now, if the distance remains the same, kindly note here it is mentioned that Girish traveled the first half of the journey distance at an average speed of 40 kilometers per hour, and the remaining half of the journey distance at an average speed of 60 kilometers per hour. If the distance remains the same, then the average speed of this overall journey, that will be nothing but the harmonic mean of 60 and 40. And that will be nothing but 2 into 60 into 40 upon 60 plus 40, that is 100. And that will come as 48 kilometers per hour. But you have to take the harmonic mean when the distance aspect, it remains the same. If the time aspect remains the same as indicated in our question, you can straight away go to the arithmetic mean of the individual speeds involved. And here in this case, it is 60 plus 40 upon 2, and that is equal to 100 by 2, and that is equal to 50 kilometers per hour. Okay, so this brings conclusion to our first question. Now let us discuss the second question. You may attempt the question now after pausing the video. All right, let us consider this question. For answering this question, let us assume the normal speed, okay, let that be equal to s kilometers per hour. The normal time, let that be equal to t hours, okay. So the distance in this case, you know that distance is equal to speed into time. So that is nothing but s into t, that much kilometers. If you read the question carefully, you can see that sorry, you can see that Alok is traveling from office to home. The distance remains the same. Okay, so we can see that in this question, Alok's car developed a problem. So he took 25% more than the usual time to reach home. So let us consider that in this case, the speed, it be equal to s dash kilometers per hour, and the time under consideration, it is given to be 25% more than the usual time. 25% more than the usual time means what? The usual time, you have to multiply it with 1.25, because 25% more is characterized or associated with the multiplication factor of 1.25. So t into 1.25. So the revised time, it is nothing but 5 upon 4 into t. So that's the new time. But with this speed and in this time, the same distance is covered. So you can now equate these two. That is s into t, it is nothing but s dash into 5 by 4 t. Okay, so we can see that the t, it gets cancelled, and from this I can see that s dash, that is the speed in this new case, s dash, that is equal to 4 by 5 times the usual speed. S dash is 4 by 5 times s. So in the question, if you observe carefully, it is asked, in this case, what is the, that is the speed in this case is what fraction of the usual speed. So the speed in this case, it is 4 by 5 times the usual speed. Okay, so for this question, 4 by 5, this will be the final answer. Okay, now let us consider the next question. Okay, just stay online. Let me share the screen here. Just a second. Yeah, it's the third question. So here, what you need to do is, yes, the sharing is now done. We know that when the distance remains the same, speed is equal to distance by time. So when the distance remains the same, speed and time, they are inversely proportional. When the distance remains the same, the more the speed, lesser the time it takes to cover the same distance. lesser the speed, more the time it takes to cover the same distance. So when the distance remains the same, speed and time, they are inversely related. In the question, it is given the ratio of the speeds of PQR. It is 3:4:6. So the ratio of the times that PQR they are going to take to run a certain distance, the ratio of the times, it will be nothing but the inverse of the ratio of the speeds. That is 1/3:1/4:1/6. You can multiply each of these terms here with 12, 12 being the LCM of 3, 4, and 6. Then you can see that the ratio of the times, it will be 4:3:2. And that is the answer for this question. Okay. Now, let us go to the next question. The ratio of the speeds of A and B, it is 3:7. So, if B takes 20 minutes less than A to cover a certain distance, what is the time taken by A to cover the distance? So, as indicated in the previous question, speed is equal to distance by time. When the distance remains the same, speed and time, they are inversely proportional to each other. So speed of A is to speed of B. It is given as 3:7. So time taken by A is to time taken by B. It will be the inverse of this 3:7, that is 1/3:1/7. And time taken by A is to time taken by B. It is as good as 7:3. So we can consider that time taken by A, it is equal to some value 7x, where x is the multiplication factor associated with this ratio 7:3, and time taken by B, that is equal to 3x. In the question, it is given B takes 20 minutes less than A to cover the certain distance. It means that this difference 7x minus 3x, that is 4x. Okay, this is equal to 20 minutes. And this gets you x, it is equal to 5. The multiplication factor associated with this ratio, it is equal to 5. So this gets you time taken by A, 7x, that is 7 into 5, 35 minutes. And we can also see that here the time taken by B, 3x, that is 3 into 5, that is nothing but 15 minutes. And now it is clearly visible, it's evident that B is taking 20 minutes less than A to cover this certain distance. 15 and 35, when you compare, the difference it is corresponding to 20. So this works fine. So for this question, the final answer, it is time taken by A to cover the distance, that is 35 minutes. So the answer, you can write it as 35 minutes. All right. Now, let us consider the next question. Traveling at 3/5 of the usual speed, a man is late by 20 minutes. Let us assume the usual speed, let that be equal to s kilometers per hour. Okay. And the usual time, let that be equal to t hours. Okay. So traveling at 3/5 of the usual speed. So you are reducing the speed here, which means he will be taking more time to reach the destination. So this man is late by 20 minutes. So I can consider that here the distance remains the same. Distance is equal to speed into time, that is s into t in this case. Now the revised speed, it is 3/5 of the usual speed, that is 3/5s. And in this case, the man is late by 20 minutes, which means the time taken, it is usual time plus 20 minutes extra. Okay, so I can write 20 minutes as 1/3 of an hour. So the new time taken is t plus 1/3. Now the distance covered, since it is the same, you can equate them. S into t, it is equal to 3/5s into t plus 1/3. All right. And here we can cancel S, and that gives you 5t by cross multiplication. 5t, it is equal to 3t plus 1. You are taking this 3 inside, so 3t plus 1. So this gets you 2t is equal to 1, or t is equal to half an hour. That's what it means. We know that half or half an hour is nothing but 30 minutes. So we got the value for t here as 30 minutes. That is nothing but the usual time taken. We can see that 30 minutes, or it is half an hour. As asked in the question, what is the usual time in minutes that is taken to cover the same distance? Since the question, it has asked you to say the usual time in minutes, you will say that it corresponds to 30 minutes, and this will be the answer for our question. Now let us go to the next question, question number 6. Here it is given, Murali traveled from city A to B at a speed of 40 km per hour, B to C at 60 km per hour. So we are considering the travel of Murali from A to B and then from B to C. Like this it is. Okay, so let me mark it here, A, B, C. Okay, the speed in this case, we can see that A to B, it is 40 kilometers per hour speed, and B to C at 60 kilometers per hour speed. In the question, it is given that the ratio of the distances AB and BC is 2:3. So AB, let the distance be some 2x kilometers, and BC, let the distance be some 3x kilometers. Okay, where x is the multiplication factor associated with this 2:3. So we can see that in this case, the total distance under consideration, it is equal to 2x plus 3x, that is equal to 5x kilometers. This is the total distance. Okay, we know that time is equal to distance upon speed. So the time taken to cover this strip AB, it is nothing but 2x upon 40, that much hours. The time taken to cover the strip BC, time is equal to distance by speed, that is 3x upon 60. You know that it is 3x kilometers the distance upon 60. Time is distance by speed, so 3x by 60 you get. So 2x by 40, you know that that is nothing but x upon 20. Same way, 3x by 60, it is also as good as x upon 20. So the total time taken, that is x by 20 plus x by 20, that is nothing but x by 10, that much hours. Okay, so that is the total time taken. You are asked to find what is the average speed of Murali from A to C. You know that average speed, it is nothing but total distance traveled by total time taken. So the average speed, that is equal to total distance traveled, 5x, divided by total time taken, that is x upon 10. You know that division is nothing but multiplication with the inverse. So 5x into 10 upon x. Okay, x and x will cancel off. So you will get the average speed in this case here as 50 kilometers per hour. And this will be the final answer for our question. All right. So let's now go to the next question. That is the 7th one. Read the question carefully. A person covered a distance from P to Q at a speed of 40 kilometers per hour. Then it is given he covered 3/5 of the distance in 2/3 of the total time. At what speed in kilometers per hour should he travel to complete the remaining part of the journey in the remaining time? So the focus is on the remaining part of the journey and the remaining time. Okay, so if you know these two, you know the distance and you know the time, you can then calculate the speed in kilometers per hour that he should travel the remaining part of the journey in the remaining time. Okay, so for that, I'm going to do this question by making an assumption. Okay, let me assume the distance between this P to Q. Okay, that is P here, Q here. Let the distance corresponds to 400 kilometers. Why 400? Because if I select 400, then I can avoid fractions in this case. Okay. So the total distance under consideration, 400 kilometers, and the total time under consideration. Okay. When we are considering, we see that the speed with which this 400 kilometers it is covered. Speed, it is given to be 40 kilometers per hour. You can see that a person covered the distance PQ at a speed of 40 kilometers per hour. So in this case, you can see that the time it is equal to distance by speed, that is 10 hours. Okay, so you got the time in this case as 10 hours. Now, let us focus on the first part here. He covers 3/5 of the distance in 2/3 of the time. So 3/5 it is already covered. It means the remaining it corresponds to 2/5 of 400. That is the remaining distance. What is 2/5 of 400? You can see that here 5, 8 times it goes. So 80 into 2, 160 kilometers. This is the remaining distance. And what about the remaining time? 2/3 of the remaining time over, which means 1/3 of this total time, 10, that is what we have to focus upon. Okay, 2/3 of the total time is already over. So 1/3 of the total time is what it is remaining, that is 1/3 of 10. So you have now the idea of the total distance to be covered and the total time. So what should be the speed? Speed is equal to distance by time. That is 160 divided by 10 by 3, which is nothing but 160 into 3 upon 10. And that you will get the answer here as 48 kilometers per hour, which means the remaining distance, 160 kilometers, he should be covering at the rate of 48 kilometers per hour, so that overall what is mentioned in the question, it is getting satisfied. So 48 kilometers per hour will be the answer in this case. Let us now go to the next question. You can see that a man covered 1/4 of the total distance at 16 kilometers per hour and the remaining distance at 24 kilometers per hour. So for avoiding fractions, the best possible way when I am considering that 2 points are there, PQ. Okay, let me consider that the total distance, okay, total distance that is equal to some value that is 4x kilometers. Okay, let me consider the total distance to be 4x kilometers. So in the question, it is given that 1/4 of this total distance, that is 1/4 of 4x, x kilometers, this much distance, it is covered at the rate of 16 kilometers per hour. The remaining distance, you know, that is nothing but 3x kilometers. It is covered at the rate of 24 kilometers per hour. So you can see that x kilometers covered at the rate of 16 kilometers per hour. Time is equal to distance by speed. That is x upon 16, that much hours. And here you can see that time, it is again distance by speed. That is 3x upon 24, that much hours. Okay, so you are getting the time now. That is to cover the 1/4 of the distance and also the remaining distance. Okay, so 3x upon 24 is nothing but x by 8, that much hours. We already know the total distance. Now we can find the total time. Okay, total time will be x by 16 plus x upon 8. That is as good as 3x upon 16. Okay, because x by 8 is nothing but 2x upon 16. So 2x plus x, 3x upon 16. That's what you are getting as the total time. So now you know the total distance, you know the total time. So you are asked to find the average speed for this entire distance of journey. That is, average speed is total distance by total time. Total distance. that is 4x kilometers divided by total time, that is 3x upon 60. So division is nothing but multiplication with the inverse. So now this will come as 4x into 16 upon 3x. And you can see that x will get cancelled off. So we have finally the average speed is 16 into 4 upon 3. Okay, this will be the value what we have. Upon further simplification, you can see that here the average speed, okay, this will come as 64 upon 3, which is 21 and 1 by 3 kilometers per hour. So this is going to be the final answer, 21 and 1 by 3 kilometers per hour. That will be the final answer in this case. Now let us move on to the next question, the 9th one. Read the question carefully. For answering this question, let us assume the normal speed, let that be equal to s kilometers per hour. The normal time, let that be equal to t hours. So by considering the first condition, when he is traveling at 30 kilometers per hour, he misses the bus by 40 minutes. We can see that here the distance remains the same. That is, this man's travel from his home to the point, to the bus stop. The distance remains the same. So we can see that here, by considering the first case, s into t, that is the normal speed into normal time, the distance, s into t, it is equal to the speed, 30 kilometers per hour. He is missing the bus by 40 minutes. It means that he is taking more time to reach the bus stop. So the time, it corresponds to t plus 40 minutes. You know that it is nothing but 2/3 of an hour. Okay. So s into t, that is equal to 30 into t plus 2 by 3. Let me call this as the first equation. Now, if he travels at 40 kilometers per hour, then also he misses the bus by 10 minutes. I can now once again write this as s into t, the distance. It is equal to 40 kilometers per hour. He is missing the bus by 10 minutes. That is t plus 10 upon 60. That is nothing but 1 by 6. Let me call this as the second equation. Okay. So from 1 and 2, it is now easy for me to equate 30 into t plus 2 by 3, the right hand side of this equation. That is equal to 40 into t plus 1 by 6. Okay, so here we can cancel 1 0 here, no problem. Let me now expand this. So this gets you 3t plus 3 2s are 6. It is equal to 4t plus 4 into 1 by 6. This is 4t, 4 into 1 by 6. That is as good as 2 by 3. Okay, so from this, further, when I take this 3t to the right hand side, I have 4t minus 3t. T, it is equal to 6 minus 2 by 3. Okay, so we can see that here, this value, okay, let me see whether I made a mistake here. 3t plus, oh my God, this is 2. I made a small mistake here. 3t plus 2, okay, because 3 into 2 by 3 is nothing but 3t plus 2, that is equal to 4t plus 2 by 3. So that gets you t, okay, that is equal to 2 minus 2 by 3, and that is as good as 4 by 3. So you are getting the value for t here as 4 by 3 hours. What is t? T, that is the normal time, the original time. That's what we assume. T is 4 by 3. Substitute the value for t as 4 by 3. You know that t is equal to 4 by 3 hours. Substitute the value for t in one of these equations. You can put it either in 1 or in 2. And that will get you the answer for speed. Because in the question you are asked to find what should be that speed that is required to catch the bus on time. So you are asked to find the value for s. So we can see that s into 4 by 3. I'm putting it in the first equation. So s into 4 by 3, it is equal to 30 into 4 by 3. plus 2 by 3, that is 6 by 3, that is nothing but 2. Got it? So from this, I can see that S, it is equal to 30 into 2 into 3 upon 4. All good? I'm just simplifying it. 30 into 2 into 3 upon 4. Okay, now I can write this 2 as 2 into 2. So you can cancel this. 2 goes in 30 here 15 times. So 15 into 3, you can see that for this question, the answer, it comes to 45 kilometers per hour. This is the conceptual input. Okay. But in reality, if options and other inputs are given to you, we can go for reverse substitution and then answer the question. Okay, it is possible for solving questions, many questions. Okay, so this brings conclusion to our 9th question. Now let us go to the last question in this particular section. Okay, the final question here. So let me load the question for you. Just a second. Okay, here we go. All right, I guess the screen is visible to you. X and Y, they are 400 kilometers apart. Okay, so X here, Y here. The distance of separation, 400 kilometers. That's given in the question. Okay, buses A and B, they left X and Y simultaneously towards Y and X, which means these buses are traveling towards each other. You can see that one is moving at the rate of 30 kilometers per hour. The other is moving at the rate of 70 kilometers per hour. So when these two objects, they are traveling towards each other, you can see that the relative speed between them, it is 30 plus 70, that is 100 kilometers per hour. When two objects, they are traveling towards each other, you have to add the individual speeds involved. So the relative speed, you are getting it as 100 kilometers per hour. So you know that the distance and you know that this is the speed. The question is at what time that they are going to meet. Let us first find out how much hours that they are going to meet. Time is equal to distance by speed. That is 400 upon 100. That is equal to 4 hours. So 4 hours since they start the journey, these two buses, they are going to meet. And you can see that they started at 7 a.m. So 7 a.m. and in another 4 hours, that is 8, 9, 10, 11. At 11 a.m., these two buses, they are going to meet. So for this question, they're asking you at what time that they will meet. You can say that they will be meeting at 11 a.m. and that will be the answer for our question. All right. So dear students, with this question, let us conclude this discussion. I request you all to attempt these questions in as many different methods as possible, because what I have presented in front of you, it is the conventional, ordinary equation method for you for better understanding of the concepts. But try to solve these questions using different methods. So with this note, let us conclude this video discussion. Thank you very much for watching. Best wishes. Thank you.